and watch what happens. So you can see that. So some things, if you look at this here, you see, properly welded, and it looks just in a copacetic state, right? And that's still very hot there. Boom. All right, ladies and gentlemen, welcome to Juliben Schools or Juliben Fish Academy. This is Juliben, your tech guy. All right, so welcome once again. In this video, we're going to show you guys how you can actually construct a welding machine using very common materials. Okay, the basic materials you will need for this welding machine is just 2 transformers coming from a microwave machine. Okay, you can use a condemned microwave machine, but make sure that you don't use a condemned transformer in the process. What actually condemns a microwave machine is the filaments and the transformers. Those are the 2 basic things there. Okay, if the filament is gone, just forget about it. If you can replace it, that's fine. So if you are able to get 2 transformers from a condemned microwave machine, you can actually design a welded machine and it will work perfectly. Now, this is the working principle, just a very quick overview. If you have 1 or 2, but 2 is usually better for a better stamina. If you have 2 transformers from a microwave machine, if you are able to disconnect the secondary winding and loop your own winding using a 4mm wire so as to achieve a voltage between 30 to 40 volts, then you're ready to weld. Now, enough of this theoretical talk. It is high time we go into the details of how to construct this and then show you how it works. In fact, the construction has been made. If you have not been able to watch the videos, just go through the playlist. You're going to see the step-by-step procedures on how we managed to get where we are right now. Okay, so right away, I'm going to show you how everything looks like, the procedures involved, and what it takes to get it done on your own part, wherever you find yourself in the world. If you have not subscribed to our channel, please do so. Click the subscription button because a lot of videos are on their way coming. In fact, we already have a lot of them listed on the platform, which will be dropping virtually every 2 months as the case may be. Subscribe and share. All right, so let's go into the details of how it works. So ladies and gentlemen, this is how it looks like. Everything is still in a very scattered way. I will soon couple it so that you have an idea of how the full picture looks like. But I have to leave it this way so that you can have a detailed idea of what everything you see here looks like. So this job I'm doing actually belongs to a client. If you need something like this, you can always contract me and then I will design anything at all. I will design the project for you and send to you anywhere you find yourself in the world. So this is a client's project work which I have done, and by God's grace it's a successful one. So let's go into the details of how it works. First and foremost, this is the power source. Okay, so the power source goes through here and then it comes here to the switch. Yeah, this is the down part of the switch. This is the top part of the switch, and this is the switch we're talking about here. So on, off, on, off, on, off, right? So by the time you put it on, 220 volts, depending on the one coming in your location. In some areas it's about 110, 115, but on the normal standard, you're expected to have between 220 to, 230 volts. So by the time you put on the switch, what happens is that the voltage coming from here will go through these 2 terminals, okay? So the first terminal is this blue wire. It travels and gets here. Now on getting to this junction, it goes through this red wire, and then from there it enters this device, which is called a voltage regulator. So the voltage regulator is aimed at doing what? The voltage regulator is aimed at either increasing or reducing voltage for you. Okay, so you can actually use a very high voltage to weld. At the end of the day, you discover that it's destroying your properties or your materials, as the case may be. So you may need just a lower voltage, a voltage slightly lower than that, so that you can work effectively. So you need something like this called a voltage regulator. So by the time you turn this knob, It increases the voltage and reduces the voltage accordingly. Now, as the 220 volts gets into this voltage regulator, it will output the required voltage by virtue of your winding here, your turning here, that will now flow into the transformer. We have two transformers here, the first and the second transformer. So on getting through the transformer, which is the first transformer, is looped back into the second transformer, and you have it here. Now, that is the first leg coming from your 220 volts. Now, the second leg coming from your 220 volt actually travels down to this junction as well. So virtually these two junctions are 220 volts, okay, when connected. And then it goes through here. From here, it enters the second leg of the transformer, and then it's looped to this level. So these transformers, if you look at them very well, they are connected in parallel, okay? Now, the reason why they are connected in parallel is so that both transformers can function as one. Both of them cannot function independently. It won't give you an output. So you must connect them in parallel. So that powers the transformers. The voltage entering the primary winding of this transformer is 220 volts. Same thing with this 220 volts. Now, these windings were designed by me. I had to remove the secondary windings that were here before so that I can achieve my own winding with 4 mm wire to give me between 30 to 40 volts. Good. So on coming to this point, what happens is that when 220 volts is set into the primary winding, it steps down the voltage to 40 volts. And the 40 volts travels, not really 40 volts per se, it steps down the voltage, or it induces a particular voltage in this winding depending on the number of turns you have. For example, what I have here is a total of 17 windings. What I have here is a total of 23 windings. By the time you add the two together, that's about 40 windings, okay? So it induces a voltage in this system. From my voltmeter calculation, the amount of voltage induced here is 15 volts from 220 volts. So 220 volts enter here, and only 15 is induced in this winding because I have just 17 winding here. Now, on coming to this second transformer, 220 volts is induced here, but what comes through the secondary winding is just 20 volts, right? So, and these two transformers are looped together in series. So you take your winding, let me take you to the back. You see how the back looks like? So this is the first terminal that goes through here, winds up to 17 turns, and then it goes through here, enters this transformer, winds up to about 23 turns, and then it comes out. So we have two terminals. This is the first terminal. This first terminal is connected to this particular knob here. You see this knob? And that is what you see outside here as the black head, okay? And this black head, I'm connecting this one to the earth, right? Now, the second leg is going through this knob here, which I am connecting straight to my handle, okay? For welding, straight to my handle. Now, the truth is that you can actually decide to swap them. There is no particular leg that should go for earth or a particular leg that should go for the handle. You can swap them, it will work. All you are doing is just to successfully spark between 30 to 40 volts induced by the two transformers. So you're sparking them together, and in the process of sparking this voltage by short-circuiting them, it gives you what you need for welding. That's just the whole concept here. Now, that is that for the two transformers. Now, if you check, we have here a voltmeter. So this is a voltmeter. This is the face of the voltmeter. As you're turning this knob, it will be reading from here. I'm going to demonstrate that so that you see very shortly. So as you turn through, the voltmeter will read the amount of voltage here that you are regulating. This is just an indicator light, okay? And then these ones are the earth. So basically that is how it works. And then not forgetting, because after using this for a while, if you touch these transformers, you will discover that they have started heating up, okay? Yeah, you can actually use this to do very, very heavy jobs, like you want to use it in gate constructions and all that. No, it will catch fire, come on. This is just an experimental setup to weld very little things. Maybe you want to fix something at home, you want to do 1 or 2 weldings just for a short period of time, won't take you 20 minutes or 15 minutes, you're done, then you need something like this. But you have to work for hours, then you have to use about 4 of these transformers. All of them look together in parallel with their windings look together in series, and that will give you more stamina for you to be able to work heavy jobs. Okay, so because of the heating that will take place in the process, there is a need for fans that will cool the system, and those are the fans you see here. Good. So I have 2 fans here connected in parallel as well. So this is the first fan, this is the second fan. Okay, now these are 2 12-volt DC fans. The big question is, what is coming in here is 220 volts. How do I power a 12-volt fan with 220 volts? All you need is an adapter. And that adapter will convert 220 volts for you to 12 volts required to power these 2 fans. And that is the adapter you see here that I forged at the top here. So this adapter actually collects AC power from here, and then these are the terminals. I'm going to connect that shortly, and then goes in here as 220, but what comes out here is just 12 volts, which powers these 2 fans connected in parallel. And that will help in cooling these 2 transformers in the course of running it. So gentlemen and ladies, this is the welding machine designed from 2 transformers coming from a microwave machine, and this is how it is. So now right away I'm going to connect everything and show you how it works. Thanks for watching, guys. So let's go ahead and work on the system and get it tested. Boom. Alright, ladies and gentlemen, behold the completed work. Yeah, this is made in Nigeria, precisely Benin City, Edo State, okay, by Joliben Schools. So this is how the amazing welding machine looks like, made from 2 transformers that you find in a microwave. So let's give it a try and see how it operates. So first and foremost, what you see here is the dashboard. Okay, so in this dashboard you find many things. We start with the handle. This you can connect to the handle, while this you can connect to the earth. You can actually swap any of the 2 and it will still give you a better result. Okay, but I just have a preference of red to handle and then black to earth. So this is my handle. I'm going to connect that later, and then this is the earth with a clip, alligator clip. I'm going to connect that later as well. So this edifice you see here comprises the following. These are the 2 areas that you mostly use for the welding process. Now what you see here is a voltage regulator, okay? You can regulate the amount of voltage entering and leaving the transformer through here, okay? And then here is a voltmeter, a digital voltmeter. It displays the amount of voltage in use at that point in time. So if you are turning this to the lowest level, it will show the lowest voltage you are reducing it to. If you want to increase, you increase from here. So it helps you regulate voltage during welding process. At times 220 to 230 volt is too high for you to weld with. So if you don't have a regulator, you won't be able to weld effectively. It will spoil your material, okay? So you have to regulate from here to have the appropriate voltage of choice. And then here is an indicator light. It's just here to show that there is power in the entire setup, okay? Then what you see here is a switch. This switch will switch off the entire system and switch on the entire system, as the case may be. And then you will see some oxygen vents around here. And then you also see some oxygen vents around here. So all these have fans from within that blows and maintain a smooth atmosphere within the welding machine. So everything you see here is copacetically done and is very strong and very rigid. You can turn it upside down, nothing is happening. So everything here is well arranged and in very, very good condition. So at this point, we are going to test run it and see how it operates effectively. So first, I would like to connect the handle. So this is my handle. I take this and I'll use this clip. First lose this. So once you lose this, the next thing you would like to do is to connect. Very easy to connect. Then put the washer. After that, screw. Sorry about that. So connect this to the washer and then screw effectively. And of course, in the process of screwing, you have to ensure it's firm. Perfect. Then you take us to the next one, which is the X, okay, with your alligator clip. And then you lose this, remove the washer, then replace and tie it effectively as well. So at this point, your welding machine is set. So all you need to do right now is to clip this to whatever you want to weld. I'm using this for demonstration. This is my hammer. It's not bad, but I just want to, weld. There are some little cracks. I don't know if you can see that through the camera. There are some little cracks around the knob head here. So I'm going to use this alligator clip, clip it, and then get it ready to be welded. So I'm clipping it somewhere here so that you can see that. Take this a little bit backward, and then put it here. I think that's a little bit better now. And then I will get myself an electrode, okay? So this is an electrode, just connect it here, and then the next thing is a power source, and then you make contact and weld appropriately, okay? So first thing I'm going to do now is to get power. Now there is no current power here, so I have to go and put on a generator to be able to start that. So in the course of trying to weld and all that, you may hear some noise in the background, but just know that it's coming from the generator. Alright, so let me go and put on the generator. So at this point, the generator is switched on, and it's time for us to start the welding, the welding demonstration. So before you start, you have to put on the welding machine. So let me put it on from here. So now I can power the machine through here. Boom. So the machine is on. We check the voltage showing here. It's 223 volts. Sorry, the camera is laterally inverted, okay? I'm using the front camera, but this is 223 volts. Alright, so at this point, I am ready for welding, but of course, I won't forget my glasses, very important. The rays that are going to be coming out from here can be very, very high and detrimental to your eye. So you have to be careful while doing that. So at this point, you start your welding. Now we want to demonstrate what happens when you use the regulator to weld, okay? We start with the highest voltage and then take it down to the lowest voltage and see what comes out of it. So if I reduce it from here, you see, it decreases. Now it's at 150 something, it's fluctuating, taking it low. Now it is at 106, 109, lower again. That's about 14 volts, okay? So 14 volts is what is entering the primary current as we speak, the primary winding as we speak. So if I take it to the lowest minimum, it seems to go up because it's almost at 0 voltage. So I'll take it up again and then it picks up. So this is 16, quite very low. So if you take it lower than that, there's no voltage, so it cannot pick up. So at this point it comes up, and then this is the highest voltage, which is 223, and that is between 220 and 230 volts. So if I'm welding at this stage, I'm using a very high voltage. So in the process of welding, maybe it's spoiling what I'm doing, it's destroying what I'm doing, I can actually reduce the voltage from here and weld at a lower voltage. Now there exists a level where you will lower this voltage and you will not be able to weld. So welding will not be possible because the voltage is too low. Okay, so let's get started and see what comes out of it. So first, I want to still weld this hammer, okay? I'll put my alligator clip just here. So you can see that. Alright, so next here is to use my handle. So this is my handle. Of course, don't forget your glasses, very important. The light rays coming out from here may not be very funny. So with this, I can comfortably weld. No, let me take it to the maximum first. So this is maximum, okay? Now, so comfortably welding. So now if I reduce, this is about 120 something to 130 something volts. So it's very difficult to weld, very difficult. Why? Because it's very low. So by the time I take it higher, maybe at 220, and watch what happens. So you can see that. So it works perfectly, and then you reduce and all that. So basically that is how it works. Some things, if you look at this here, you see, properly welded. It looks just in a copacetic state, right? And that's still very hot there. So if you need something like this, you can always call on me. My phone number is displayed on the screen. You can call on me, subscribe to our YouTube channel, and you will definitely see as many other videos as possible. This is a project work done for a client. If you need something like this or any project work at all that has to do with electrical work, just let me know. And even mechanical work, we can design that and send to you anywhere you find yourself in the world, okay? I designed the fuelless generator before. You can check my YouTube channel, go to the technology part of the playlist and you're going to see them there. Just go through it as well and see how an engine works without fuel, without water, and without oil. Thanks for watching. This is Chulaman Schools. Boom. And Chulaman Fish Academy as well. Boom.